times cosine x minus cosine x. This is factored the same exact way as that. Let's factor this first. So if this was on a factor drill, what could you take out of both of these? Let's do that. So that's going to leave x squared minus, what goes here? 1. Yeah, good job. And y'all look in here. Can you keep going with that? Yeah. So if I factored this completely, that's factored completely. You do the same process, it just has more letters. You're just looking at more letters, the math is exactly the same. Alright, so if you notice here, this term has cosine x and this term has cosine x. We're going to factor out cosine x. So I'm going to write cosine x and then write what's left over when I factor it out. When I take it out of this first term, that leaves sine squared x. When I factor it out completely, 1 is the placeholder, so minus 1. And then sine squared x minus 1, this is a difference of 2 squares, as long as that's a minus sign, and as long as that is a perfect square, which it is. So to break this up, it is going to look like that. We're just going to write sine in front of both of those x's. You have 2 signs right here. See this squared? We're going to break up both of those signs. So there's 2, there's 2. And then a difference of 2 squares is minus 1 and plus 1. And don't forget to put your GCF back down in the final line of your work. And that is completely factored. That is the answer. That's how example 4 works. Let's look at example 5. All right, so for example 5, it is going to be sine squared x minus 3 sine x minus 10. And I'm just going to write out to the side like an algebra looking problem. You're going to factor this the same way you would factor this. Minus 10. Alright, so we need numbers that add up to a negative 3 but also multiply to a negative 10. That's going to be a negative 5 and a positive 2. So if I factored this, it would be x minus 5 and x plus 2. It's going to look pretty much the same. I'm just going to have the sign written in front of these x's. So this is going to be sine x minus 5 and then sine x plus 2. And that's going to be completely factored. All right, let's look at one more example. So for this next example, our final one, write down secant squared x minus tan x minus 3. And then, in my notes I wrote, nope, you cannot factor that. They all have to be the same trig ratios. All must be same trig. You can't mix. Guys, if you look at this secant squared, and if you look at your trig IDs, what does secant squared equal? 1 plus tan squared, right? Let's just substitute in. We know secant squared x is 1 plus tan squared x. I'm going to bring down the rest of the problem. And then we got to combine some like terms here. So a positive 1 and a negative 3, that's going to be a negative 2. So we're going to have tan squared x minus tan x minus 2. And remember, that's just like x squared minus x minus 2. And numbers that multiply to a negative 2 but add to a 1 are going to be a negative 2 and a positive 1. So that's going to be the answer for this. We're just going to write the letters tan in front of it. So tan x minus 2 times tan x plus 1. And that's going to be completely factored.